everyone. I want us to look at current electricity. There is a question I'm trying to explain from KMF, current electricity 2, number 1, but I'm not doing exactly what is asked. I'm doing it to help you remember the basics. So the diagram is like that. Up here, our source is 2 volts. Then there is this resistor, 2.5 ohms, and there are 3 in parallel. So really what I'm trying to remind us is how to combine resistances in parallel, in series. Okay? So anytime we have them in parallel, we use 1 over R, that is, I'm trying to get the effective resistance, or in other words, 1, which will replace all these 3. So you use the formula 1 over RT is equal to 1 over 6 plus 1 over 3 plus 1 over 6. When you compute that, you get 4 over 6. Now that is not the answer, because that is a reciprocal of resistor we want. So I come 1 over RT is equal to 2 over 3. Then cross multiply, you get RT is 3 over 2 or 1.5. So that is how we get effective resistance of those who are arranged, of which are arranged in parallel. So this. Now we have replaced these ones with only one whose resistance is 1.5. So what happens? 1.5 to replace this, and here 2.5. So those two will be in series, and we get resistance across XZ. Resistance across XZ. 2.5, 1.5 gives me 4. Very good. So get that. These are points that you must remember. Now from there, anytime you get total resistance, okay? In other words, the core thing here is V is equal to IR. See? V is equal to IR. Now I have total resistance and I have the PD of the source. So I should be able to get the current. So here, if I may focus now down, our focus is down here. There. What is current from the source? Current from the source will be V over R. V is given as 2, and our total resistance here is 4. So current from the source is 0.5. Again, I take you back a bit. So the current that is coming from this source is 0.5. It is coming. The current coming is 0.5. When it reaches here, part will go up, part will go direct, part will come down. So the one which goes up, I've designated I1, this one I2, and the last one here I3. So you have the right thing. What do you know about the resistors in parallel? Their PD is the same. Their PD is the same. Okay? PD across here is the same as that, is the same as that. Okay? So, I can ask you to get me current I1 or current I2. I can ask. Before you get it, remember the core thing is V is equal to IR. So, anytime you are asked, you quote this formula. 2 components will be given, then you look for the third one, the one which is missing. Okay? So I have an example here. We again focus down there. Okay? So PD across YZ, PD across here. I can get it in 2 ways. The effective resistance I had was 1.5 here. The effective resistance I had, a single resistor whose resistance is 1.5. If I multiply by the current through it, I get the PD across here. Alternatively, we focus up again. I know that this current, it will be the same passing here again. So I can get the PD here, 2.5 times the current. This current we got 0.5. So this current, it comes here, it divides. But when it reaches here, it meets again. It comes out as 0.5. So 0.5 times 2.5 gives me 1.25. So the PD here, subtract from 2, you get the P here across the 3. So 2 ways you can use. Now open your mind and get the substance. Now we come back. We reason again back. Here, the PD 1.25, 2 minus 1.25, we get here. An alternative method, I took the effective resistance here multiplied by the current. So this is I, the current, that goes through the effective resistance 1.5. You get 0.75. 2 methods, you get the same. Now I want to show you how do you get any of the current. I've already known the effective PD here. It is the same. You apply it across here. 0.75 is the effective PD. It is equal to I1 times 6, or 0.75 is equal to I2 times 3, or this. But this and this are the same. So I1 and I3 will be the same. So I've done for I2. What is the current through 3 ohm resistor? The current through 3 ohm resistor will be 0.75 is equal to I2 times 3. Therefore, I2 is 0.75 divided by 3, which is 0.25 amps. Okay? Those are basics. Now, I focus here to conclude. Our core thing is V is equal to I, R. For any letter here, you must know its role in series and in parallel. V in series is the total of individual PD. V is equal to V1 plus V2. V in parallel is the same, where these are resistors. So V across resistor 1 is the same as V across resistor 2 is V across resistor 3. They are the same. This is parallel P. Series V is that. Now you have to go and uchambue what happens to current, what happened to resistance. So that next time I'll show you about capacitance, charge, and PD. Okay? It will be about capacitance. If this is very clear, you will find it very easy, because in both resistor and capacitors we have V. So that one will be done. You will be done. Resistance is compared to capacitance, and therefore charge is compared to current. So if you know how current behaves here, it will be very easy to comprehend charge. That is assignment. Do it, my friend, for your own good. Bye.